In the name of God. Hello, dear students. Welcome back to Farkhwa's website. My name is Masood. I'm a physics teacher. We are here in Farkhwa's website to explain physics curriculum, grade 11. Our goal is to make the curriculum easy for you as much as possible. In previous lesson, I talked about free fall. And free fall is a phenomenon by which an object moves vertically near the surface of planet under the only action of gravity of the planet. And I told you in previous lesson that free fall is not dedicated for Earth. It's true for all celestial bodies. Some demonstrations actually was taking place over the surface of Moon, for example, in 1971 by David Scott. That's why free fall actually is not just for Earth. Free fall means the motion of any object vertically, whether the motion is actually throwing up or falling down, it doesn't matter. The motion should be vertical, whether the direction is upward or downward. And free fall should be taking place near the surface of planet under the only action of gravity of the planet, regardless regardless of the action of other forces. And whenever you say near the surface of planet, means you ignored air resistance, you ignored friction. So any motion near the surface of planet is considered to be free fall. Right. And for free fall, there are two properties in our textbook. Let me read them for you. Properties of free fall. Number one, freely falling bodies undergo constant acceleration. So they experience constant acceleration. This is the first property. The second property, freely falling objects always have the same downward acceleration. So the direction of free fall objects is always downward to the center of the planet. So the first property concentrates on the magnitude of acceleration, which is a constant acceleration. And the second property focuses on the direction of free fall, which is directed toward the center of the planet. We want to study these properties one by one. The first one, number one, the first property, freely falling bodies undergo constant acceleration. Let's elaborate this property. Freely falling bodies undergo constant acceleration. We have a figure over there. Let me read the explanation regarding the figure. It says figure below shows a strobe photograph of a feather and an apple. There's a feather and apple, two objects with different masses. One is very light, like feather, about, for example, 5 or 10 grams, and the other is more massive with respect to the feather. It's almost, for example, 100 grams. So both objects are different in mass, releasing from rest in a vacuum chamber. There is a vacuum chamber. This vacuum chamber actually is analogous to the outer space, because here air is evacuated from the chamber, and there's no retarding force within the vacuum chamber except for gravity. Only gravity, let's say, brings the apple and further down. Only gravity is in charge of falling the objects down. That's why this motion is considered to be free fall. And whenever you take a look at these objects, you see that the objects, regardless of their masses, they move down side by side. So they travel the same displacement, they travel the same velocity, they pick up the same acceleration, which is the acceleration due to gravity of Earth. That's why whenever you analyze these objects, whenever you study these objects, you see that the apple and feather actually landed on Earth, landed on the surface of Earth simultaneously. That's why actually in the absence of air resistance, objects fall at the same rate, at the same velocity, with the same acceleration. And I told you this is the Galileo's thought, and this is confirmation of Galileo's thinking. So by this vacuum chamber, by using vacuum chamber, you can refuse the Aristotle thought, because Aristotle said that let's say heavy objects fall faster than lighter one, and it's completely wrong. We don't believe this. Maybe you say, teacher, whenever you do this experiment, whenever you actually you fall feather and for example hammer, or apple and feather, you see that the apple falls faster than the feather. If you are able to evacuate a location, so you can observe that the objects, regardless of their masses, landed on the surface of Earth simultaneously. And whenever you define a free fall, you should mention in the absence of air resistance, right? Or in the presence of only gravity of planet, free fall is taken place, right? So it says we have to study some factors regarding the vacuum chamber. What are these? Number one, time interval. We have to study time interval. We have to take time interval into account. Time interval remains constant between successive pictures. What does it mean? Means time passes equally. Time passes equally. For example, the first time interval is 0 second. These objects start from rest. After that, after, for example, 1 second, they travel a particular distance. After a second time interval, actually they traveled the same. Actually, they traveled another displacement, and displacement is increasing by the same amount. We cannot say displacement is constant. Displacement is increased by the same amount. Let me let me give you an example numerically. For example, the first displacement, is, for example, at time t is equal to 0, I can say displacement actually is maybe 9. I say 9.81. Excuse me. Let me change the number. I'm going to change the number. At time t is equal to 0, the object starts from rest, means velocity is equal to 0, and displacement delta x is equal to 0 as well. Delta x is equal to 0. What do you predict about the next time interval? What happens after a while? Displacement increased by the same amount. Excuse me. displacement increased by this value, 9.81 meters. Right. What else? What happens after between successive time intervals? Displacement is increased to 1962 meters. What else? Right? Predict another situation, another displacement, delta x is equal to, and actually 29 point, for example, 29.7, and so on. So whenever you subtract the smaller displacement from the larger one, you get the same value. That's why displacement is increased uniformly by the same amount. So the motion is uniform because displacement is increased by the same amount. So we have a uniform motion. Number 3, velocity increases by the same amount in each time interval. Like actually displacement, velocity increased by the same amount. So we have the same situation for velocity. Whenever you divide these numbers by time interval, you get the same values. For example, from 0 to 1 second, velocity becomes 9.81 meter per second. From 1 second to 2 seconds, it will be 19.6. From between 2 and 3 seconds, it will be 29.7 and etc. So velocity and displacement are increased by the same amount over time. Right. What do you say about acceleration? Acceleration, both objects gain a constant acceleration. So displacement is increased by the same amount. Velocity is increased by the same amount, but acceleration remains constant. Both object, apple and feather, they get the same acceleration, which is the acceleration due to gravity or free fall acceleration. And because the difference between, for example, velocities is the constant, and the number is 9.81, right? And the direction directed toward the center of Earth. That's why you have to put a negative for this value. So change in velocity is constant. Change in velocity is taking place over time, means acceleration is constant, means we have negative 9.81 meter per second squared. This is the actually acceleration. So both objects pick up the same acceleration while they have different masses, because here we neglected a resistance, vacuum chamber. Actually, in vacuum chamber, there is no air. Air is evacuated from the vacuum chamber. That's why both objects land on Earth simultaneously. So they are consequence of this experiment. Let me read a note for you. We have a note here. Let me read it for you. We have a tip. By reading this tip, I'm going to finish the lesson, and I leave the second property of free fall for the next lesson, God willing. So tip, within each time interval, both objects, regardless of their masses, move side by side. I think I explained it for you. Both objects, regardless of their masses, move side by side with the same acceleration, which is a free fall acceleration of Earth. G is equal to negative 9.81 meter per second squared. So keep in mind that actually free fall acceleration is constant for any planet. For example, for Earth, free fall acceleration is denoted with g and is equal to negative 9.81 meter per second squared. For other planets, actually free fall acceleration is different. For example, for Mars, we have negative 3.7 meter per second squared, approximately one third of free fall acceleration of Earth. Because Mars is smaller than Earth, the smaller the planet is, the smaller the acceleration is. And let me give you another example of another celestial object like Moon. The acceleration due to gravity of Moon is negative 1.6 meter per second squared, approximately one sixth of free fall acceleration of Earth. Thank you very much, guys, for watching this video, and bye for now.